Now on this problem, a certain radioactive element decays over time according to the following equation. Many times it'll give you guys an equation that you must use, and you basically just have to plug in the information. Now A stands for the number of grams present initially, T is the time, so we basically just have to plug in two numbers, the value of A and T. If 6,000 grams were present initially, that will be the value of A. How many grams will remain after 9 years? That will be the value of T. We have Y is equal to A 1/2 T over 3. So let's go and plug in the information that they give us. Y is equal to A will be the initial amount, which is 6,000. 1/2 T will be the number of years, which is 9. 9 over 3. We're going to simplify the exponent. So 9 divided by 3 will be 3. We are going to expand this 3 times. So it'll be 1/2 times 1/2 times 1/2. But let's go and expand it. 1/2 multiplied by 1/2 multiplied by 1/2. Now when we multiply a whole number by fraction, we're going to place it over 1 and we're going to multiply across. 6,000 times 1 times 1 times 1 will be 6,000. 1 times 2 is 2. 1 times 2 is 2, times 2 is 4, times 2 will be 8. So it'll be 6,000 divided by 8. You can reduce if you want, but we're just going to do the long division. 6,000 divided by 8. 8 goes into 60. 7 times 8 will be 56. Subtract, this is 40. Bring down the 0, that will be 40. 8 divided by 40 will be 5. 5 times 8 is 40. Is 0. So it'll be 750. The answer will be B. So after 9 years, you're going to have 750 grams left. Remember, this is an exponential decay, so it decays very quickly. It's an exponential decay because this 1/2 is less than 1. Let's go over another example. A radioactive element decays, so it's an exponential decay, it's 1/2, over time according to the following equation. So they give you guys an equation that you need to work with. And they tell you that A represents the number of grams present initially. Well, how many grams do you start with? And T will be the time in years. If 7,000 grams were present initially, how many grams will remain after 15 years? We're going to substitute the information they give us into the equation. So let's go and write down the equation first. A 1/2 to the exponent of T divided by 3. This will be Y is equal to A corresponds to how many grams are initially present, which is 7,000. 1/2. T is the number of years, so it'll be 15. So 15 divided by 3. This will be Y is equal to 7,000. 1/2. 15 divided by 3 will be 5, so we simplify the exponent. I'm going to go ahead and rewrite this 5 times. With 7,000 multiplied by 1/2, multiplied by 1/2, multiplied by 1/2, twice more, 1/2, and one last time. Now, to simplify this, because I'm multiplying a whole number by fractions, I'm going to place it over 1, and I'm going to multiply across. 7,000 times 1 will be 7,000. 1 times 2 is 2, 4, 8, 16, 32. Now, we can reduce if we want, or we can just go and do the long division. I'm just going to do the long division, 7,000 divided by 32. 32 goes into 70. I know that 32 times 2 is 64, so it'll be twice. 2 times 2 is 4, 2 times 3 is 6. Subtract, and then the next number. 32 goes into 60 only once. 1 times 2 is 2, that'll be 3. Subtract will give you 28. 32 goes into 28. Let's look at our answers. We have 200 and so it'll be 8 times. Our answer will be letter B, 218.8. And we can continue just to be able to get the exact answer, but you should be able to get your answer from there. Let's go over one more example. And if you guys notice, the wording stays the same. On your test, it might be different. Just focus on the equation they give you and plug in the information that is provided for you. Then you just have to simplify afterward. A certain radioactive element decays over time according to the following equation, where A is the number of grams present initially, and T is the time in years. If 3,000 grams were present initially, how many grams will remain after 12 years? So let's go and plug in the information that's given to you. Let's go and write down the equation first. Now, y is equal to A is the number of grams present initially, which will be 3,000. 1/2. T is the number of years, so it'll be 12 divided by 3. We first want to be able to simplify the fraction, the exponent. It'll be y is equal to 3,000. This is 1/2. 12 divided by 3 will be 4. Now, we want to be able to, do not multiply. We want to be able to raise it to the power of 4 first, so we're going to expand. It will be 3,000. Be 1/2 times 1/2 times 1/2 times 1/2. And we're going to be multiplying across. When we multiply a whole number by a fraction, we want to place it over 1. So it'll be 3,000 on top. Denominator will be 1 times 2, 2, 4, 8, 16. So it'll be 3,000 divided by 16. We're going to do the long division. 16 goes into 30 only once because twice will be 32. 1 times 16 is 16. Subtract gives you 14. Bring down a 0. 16 goes into 140. I believe 8 times. And if you go at your answers, we're going to guide ourselves. I believe it's D, but let's go and double check. 8 times. 8 times 6 is 48. Carry 4. 8 and 4 is 12. Subtract will give us 12. Bring down a 0. The next one should be 7. 7 times 6 is 56. Carry 5. 7 and 5 is 12. 7 is 42. Carry 4, and that'll be 11, and that'll be 8. So your answer will be 187.5. Please email me if you have any additional questions. Have a great day. Thank you.